If we misunderstand black holes, we risk missing the universe's deepest secrets. Our grip on reality might depend on what time truly does in these shadowy regions. What if time could freeze, loop endlessly, or let you glimpse the universe's final moments, all inside a black hole? This might sound like science fiction, but real physics suggests time behaves in bizarre ways near these cosmic monsters. Black holes are not empty voids. They twist realities so intensely that time itself can stall, repeat, or even shatter. Crossing their boundary means entering a realm where the laws of nature unravel, and nothing, not even light, can escape. Picture yourself standing at the event horizon, peering into a place where every law of physics teeters on the edge. For decades, scientists have tried to unravel these mysteries, and some believe the truth about time inside a black hole could outstrip the wildest stories. To understand these stakes, we need to explore how time truly behaves near a black hole, and why scientists are so captivated by its paradoxes. Einstein's general relativity revealed that gravity is the warping of space and time. The greater an object's mass, the more it curves the fabric of reality. Both space and time bend, not just space alone. Gravity is not just a force. It is space and time themselves bending under the weight of mass. When a colossal star dies, it can collapse into a singularity, a point so dense that the known laws of physics unravel completely. This produces a stunning phenomenon called time dilation. Where gravity is stronger, time slows down. On Earth, this effect is tiny. A clock at your feet ticks a fraction slower than one at your head, because your feet are nearer the planet's center. What actually happens to time at the edge of a black hole? Here is where reality begins to break down. But near a black hole, time dilation turns severe. As you approach the event horizon, the invisible threshold of no return, time itself drags almost to a halt compared to the universe outside. Grasping these basics is vital, since missing how gravity manipulates time obscures why black holes are so unsettling. To truly understand black holes, we have to follow time as it twists past the event horizon. Inside, the rules of the universe start to crumble. At the edge of a black hole, time itself bends in ways that seem impossible. To a distant observer, anything falling toward the event horizon appears to slow down and freeze, trapped on the brink forever. This is the black hole time freeze paradox, one of the strangest consequences of Einstein's theory. Yet, for the astronaut, nothing feels unusual. They cross the event horizon in what feels like a normal span of time, with no warning, no barrier, no sense of crossing into the unknown. Their clock ticks onward, totally unaware of the cosmic freeze that outsiders witness. As the astronaut nears the edge, their image fades and lingers, seemingly frozen just outside the point of no return. Information about their fate takes longer and longer to escape until it vanishes completely. This is not just a trick of light. Time really does flow differently for them compared to you. Picture an astronaut drifting closer and closer to a black hole. From far away, you would see them move in slow motion, their actions stretched out as if the universe itself pressed pause. Light leaving their body gets dragged and delayed by the black hole's immense gravity, and time near the event horizon runs slower than anywhere else. So, which story is real? Both are. In the warped world near a black hole, reality splits depending on your point of view, reminding us that time itself is not absolute, but shaped by gravity and motion. If we ignore these paradoxes, we risk missing the true strangeness of the universe and misunderstanding the fabric of reality itself. But what if you could follow the astronaut inside? The true mysteries of time and space only deepen beyond the event horizon. Inside certain black holes, time is stretched so far it almost loses meaning, or could even loop back on itself. What if the wildest science fiction concepts, like time travel or cosmic shortcuts, are not merely fantasy, but real features hidden deep within these cosmic enigmas? Inside these loops, cause and effect start to break down. Paradoxes become possible. Could an event trigger itself? Could information appear from nowhere? These riddles are not just theoretical puzzles. They force us to question the very foundations of the universe. Approaching a black hole's singularity, time dilates to an unimaginable degree. For someone falling in, only seconds pass, while the universe outside could flash forward by billions of years. From within, moments blur. From the outside, entire eras vanish in an instant. Time itself seems to unravel, making reality nearly unrecognizable. But the story grows stranger. Spinning black holes twist space and time around them, dragging both into bizarre contortions. This extreme rotation could, in theory, create closed time-like curves, actual loops in time. Someone could travel around such a loop, returning to their own past, meeting an earlier self, or replaying moments endlessly. There is an even wilder possibility. Some physicists suggest that black holes might connect to white holes, places where matter and light erupt outward. This bridge could form a wormhole, a tunnel through spacetime linking distant regions, times, or even universes. Instead of being dead ends, black holes could be cosmic gateways. Exploring these ideas could reveal entirely new physics and transform our understanding of the cosmos. Turning away means missing out on the universe's deepest secrets. But how close are we to proving or disproving these astonishing possibilities? To find out, we must look for clues both in theory and in the signals black holes send across the universe. Yet, stable wormholes would require bizarre substances like negative energy, which remain purely hypothetical. So far, there is no evidence for such materials. But if they exist, shortcuts across space and time might truly be possible, overturning everything we know about reality. We may never set foot near a black hole, but with groundbreaking technology, we are finally prying open their secrets. The Event Horizon Telescope, a worldwide network of observatories, gave humanity its first image of a black hole's shadow. This momentous feat revealed how space and time twist and stretch at the very brink of the unknown. Einstein's idea that time would freeze at a black hole's edge is now supported by direct evidence. Still, questions linger. What truly happens beyond the event horizon remains unsolved. But images are only part of the story. Gravitational wave detectors like LIGO and Virgo have opened a new window on the universe, catching faint ripples from distant black hole collisions. These waves let us study invisible objects and deepen our grasp of cosmic mysteries. Soon after, scientists used the same globe-spanning telescope to capture the image of Sagittarius A star, the supermassive black hole at the core of our Milky Way. For the first time, we stared into the heart of our own galaxy and met the gravitational giant holding it together. That is why physicists are racing toward a theory of quantum gravity, hoping to merge general relativity with the bizarre rules of quantum mechanics. Such a breakthrough could unlock secrets about black holes and reality itself. We have glimpsed the edge of the abyss, but what lies inside remains the greatest mystery. To understand time inside a black hole, we must venture beyond the limits of our current knowledge. By staying curious, you become part of humanity's quest to expand the limits of science and imagination. This is not just about distant shadows. It is about reshaping our understanding of existence. Time inside a black hole is not just a theory. It is a direct challenge to the very laws that shape our universe. Black holes do not simply stretch the imagination. They tear holes in everything we think we know about reality. When we ask what really happens to time in a black hole, we are not chasing science fiction. We are peering into the deepest riddles physics can offer. So next time you gaze at the stars, remember, black holes are not ends. They are signs that the cosmos still hides wonders beyond belief. Stay curious. You might help discover the next great truth. Your curiosity is not trivial. It is essential. If we stop asking questions like these, the universe's greatest secrets will stay forever locked away. The next leap for humanity depends on those bold enough to look into the unknown, to doubt, and to imagine beyond boundaries. This is not idle speculation. The physics of time near black holes could force us to rewrite our understanding of space, energy, and even the origins and fate of entire universes. The ideas sound wild, time freezing, looping, or doors to other realities, but they are grounded in real equations, experiments, and the relentless curiosity of scientists who dare to ask, what if?